Okay, we're going to talk about one more type of circuit today, and that's using the photoresistor. I've seen a lot of really interesting works of art that you interact with from a distance. So sometimes you wave your arm in front of it using a motion sensor, or you put your hand close to it with a distance sensor. And we're going to experiment with a photoresistor that can make your components react depending on how much light is on them. This is a common kind of thing to use in like a music box. So if you opened up an electronic music box and it was exposed to the light, then maybe it would play the music inside. So you could make artwork that when you shine a light brighter on it, then it changes what it does. So with this circuit, you're going to need to look in your kit and find the photoresistor. And it's a wee little thing. It has two legs like an LED has, but the top is definitely different. The top is flat and has a red squiggle on it. So you'll need one of those. And you'll also need a 10K resistor. So find your 10K resistors and grab one of those. I'm going to use the same basic circuit as the servo that I had before, but I'm not going to use the push button, so that's going to go away. Trying to delete it. I'm not going to use this wire. This wire that goes to pin 4 was for the push button. That can go, and that wire is going to go. But I will keep the 10K resistor because that's, from the pack. So I'll just rotate it a little bit. There we go. So let's find a photoresistor. And there's one right here in my circuit kit. So let's grab one of these and pull it out there. So it looks really similar in Tinkercad to what you're working with. And me, I'm going to rotate it. There we go. A photoresistor is just a resistor, kind of like this one. It slows the flow of electrons. And the way it works is the electrons flow faster and it has less resistance when you shine light on it. And the electrons flow slower and it has more resistance when there is less light on it. So we put it in series with one of these little resistors here, and then it kind of acts like a potentiometer. You know how a potentiometer has a 5 volts pin, it has a ground pin, and then the pin in the middle is the sensor pin that you read. We're going to configure these so it's configured the same as a potentiometer. You just don't turn it, you just cover the light. So take your photoresistor and put the two legs in two different numbered rows. And then take your 10K resistor, and we're going to put one leg in the same numbered row as your photoresistor, and the other leg in a completely different numbered row. Okay? I don't want to put a wire there yet. I'm not quite ready. Okay. So photoresistor, two different numbered rows. Regular 10K resistor, one pin is in the same row as one leg of the photoresistor, and the other leg is in a different row. So as we did with the potentiometer, we're going to connect one pin of these to 5 volts. So I'll start with the photoresistor end and connect this to 5 volts. That's my power rail on the breadboard. There we go, and we'll change that to be red. And then the bottom pin, the one that's the lonely leg of the resistor, this is going to get connected to ground. So we'll connect that to GND. And then this row that has both the photoresistor and the regular resistor in it, this is going to be our sensor pin. So take a jumper wire from this row, the one that has photoresistor and regular resistor, and that's going to go over to analog. You can use analog 0, analog 1. Well, I'll use analog 1 today. So that goes to analog 1. 5 volts, analog 1, ground. Before I have my resistor control anything, I need to see what kind of readings it gives me. And you'll need to do this too. Don't use the same numbers that I'm doing because every circuit can behave a little differently here. So we'll go to the code, and right now my code is set up for a push button. So I'm going to get rid of everything in void loop. I don't need this pin mode 4 input, and everything else should be good. Notice I've got a variable up here that says int btn. I'm going to change that since I'm not using a push button anymore to int photo. Okay, so in void setup we have s.attach9. Nothing in here needs to change. Our servo is still going to be attached to pin 9. In void loop, this is where things can get a little different. So we're going to read our sensor pin, photo, TO, equals analog read A1. And that's a capital A and a number 1. And then I'm going to use the serial monitor to write this out so I can see what kind of readings I'm getting. So in void setup, I need to set up the serial monitor. And then in void loop, I'm going to use the serial.println statement to write the reading from the photoresistor to the screen. Print ln photo. I can't type today. That's photo, all lowercase, just like that. So I'm going to leave it like this for now. We need to see what kind of numbers we're getting before we can have that photoresistor control control the servo motor. So I'll start the simulation. Now, if you're working in the Arduino environment, when you start the simulation and you have your Arduino set up, you're going to push this little magnifying glass in the corner to see the serial monitor. That's where it'll be for you. And if you're working in Arduino Create, you'll see the little magnifying glass off to the left-hand side, and it says serial monitor. So I've got it running, and I'm going to look at the serial monitor by, it's hard to see on my screen, but at the bottom of my my code area, there's a window that says serial monitor. Click that, and then I see I'm getting readings of 54. And I don't know how to change that reading in this setting. How do I shine light on the photoresistor? Oh, that's cool. If I click on it, I can actually get a little gauge so I can shine light. So let's say I make the light a little brighter. See how I'm getting numbers that are higher and higher? And so on my sensor here, I can get readings all the way up to 970 if I shine a really bright light on it. When I've done this experiment in a darkened, like a regular classroom, sometimes the highest reading that I can get is like 700. Sometimes the lowest reading I can get is around 300. So play around with it until you find what's the value of light that you would want to make it turn the servo on, or what's the value of dark. So maybe I want to make it so that it's normally bright, but when I put my hand on it, it turns the servo. So I will check for a reading that's below, say, below 700. And if the reading goes below 700, then I'll turn the servo. I'll just do that in my code, but you'll want to play with the threshold that works for you. Stop simulation. So here's where I'm going to add an if statement. If, and inside the parentheses, I'm going to add a condition that says if my photoresistor is less than 700. So photo is my variable. Less than is this little alligator going this way. And then check your logic. This will activate the code in between the curly braces if photo is a smaller number than 700. So if that's the case, then I will do s.write 90. So I'll turn it to 90 degrees. However, we'll do an else. If photo is not less than 700, then we'll do s.write 0. So if I start the simulation again, I can click on my photoresistor, so you see it's dark. It's like there's a hand over it, so it turned to 90 degrees. But as soon as I take my hand away and shine light on it, then it turns back to 0. And I can cover it again, and it'll turn back to 90 degrees, and I can lift my hand up, and it turns back to 0. So a photoresistor is one way that you can interact with a piece of art from a distance, or you can make like daylight sensitive art, like a solar lamp or something like that, a flower that blooms during the day. Who knows? I hope you enjoy playing around with sensors a little bit, and notice you have other sensors that are in your pack as well, and we just played around with a couple of them today. So thank you for paying attention. You've finished your Arduino lessons for the week, and if you find that you'd like to use an Arduino to make your final art project, I'm happy to help you learn about other components in the pack, and so let me know how I can help you.